Okay, Algebra 1, this video is meant to show you the formula sheet and the calculator on the state test. So the formula sheet's right up here. You will get a paper copy. So when you click on that button, it opens up kind of small. You can bring it big if you want to. Now, to be honest, this formula sheet has no real use for you. The conversions are not for you, trigonometry is not for you, area volume is not for you. The only thing that is meant for you is the quadratic formula, which is right here. Again, we just recently talked about that actually in class. So for the quadratic formula, it's a way to solve quadratics works anyway, or for any type of quadratic equation in standard form. Okay, so there's that, and again, you'll get a paper copy as well. You can make it go away and come back if you click the X and then bring it back. You can make it go full size or smaller, and again, X goes away. Okay, then the calculator. Of course, this is very similar to the Desmos graphing calculator. When you click on it, it's going to open up small, right? You can make it bigger like this. You can make it full size like this. You can make it go away and come back. Okay, you can make it smaller. Okay, so first off, the scale, right? I do not like the 0, 2, 4 scale. Sometimes that's the default, right? I like the 0, 5, 10 scale because everything's worth 1. So let's talk about some important buttons on Desmos or this calculator. First of all, square root, right? So if you take a square root of a number, so square root of 9 is 3. Okay, if you have to square a number, so 3 squared, there's the a squared button. 3 squared is 9. If you have to raise a number to a different exponent, not a squared, so you could do this ab. So say I want to do an exponential function like 3 to the x, so 3abx, and there's the graph of that. Okay, so those are some important buttons you'll need to know. Everything else can be done on the keyboard. Okay, so graphing, right? That's what this thing does. So if you get a linear equation in slope-intercept form, so like y equals 3x plus 1, type it in, graph it away. If you get it in standard form, so like 2x plus 3y equals 6, graph it away. All right. It cannot do one variable equations. So if you notice, those two equations had x and y. It cannot solve an equation like this, x plus 3 equals 2x minus 5. Notice nothing happens. It even gives you an error message here, right? So this is a linear equation in one variable. You have to solve it using inverse operations and moving things across the equal sign. Okay, so sorry about that. It does do inequalities, right? So if you remember, we talked about inequalities. The symbols are right here. So say you want to do y is less than x plus 1. Notice the shading and the dashed line, right? Now if I change this less than to less than or equal to, notice now you're a solid line. Okay, and again, you can turn it off and on if you need to. It'll do 2 as well. So if you had y is greater than or equal to, or let's just do greater than 2x minus 3, not 2 greater than. There you go. And remember, when you do these systems of inequalities, it's the overlapping shaded region. Notice that the color is different here. It's in purple. That's where the two regions overlap. And again, you can always test points if you just plot a point. So say you want to see if -3, -5 is in there. If you go parentheses -3, -5, you can see that that point lies in the solution space, right? So again, that's kind of getting techie or technical with inequalities from topic 4, but there you go. What about functions? All right, let's take a look at functions here. So if I have a quadratic function, f of x equals 2x squared minus 5x minus 9. There you go. Okay, so that'll graph it. You can make this a systems, right? If you have two equations, so like y equals 2x plus 1. Notice here, if you hover over the points where they intersect, again, you have to move the graph. You can see where they do intersect here. Okay, so that's how you solve a system. You can make a function into a table very simply by pressing this gear button, and right here, this convert to table button. Notice here to list all the nice kind of points from -2 to 2 as your x values. They'll also show up in your graph here, so like -2, -1, -2, right? That kind of fun stuff. You can add points to this table, so if you just click on the table, you can add like the next 0.3. You can even do like 3.5, right? And it'll evaluate things for you and keep adding them to the picture. You can also evaluate functions down here. So say you want to define what f of 3 was. So f of 3, it'll give you the y value -6. Next, let's talk about fractions, right? So say you want to put a fraction in. right? So like 5 over 11, but you need the exact answer. It does have the fraction button for you, so it'll put it back in there. Now say this was like 10 divided by 22. That is not simplified, right? It's the same fraction, but not simplified. You could press the fraction button to simplify the fraction for you as well. Okay. And then last but not least is our tables and our regressions, right? So if we want to add a table of values, and I'll just add some numbers, so like 0, 5, 1, 7, 2, 8, 3, 10, right? And let me bring those into view, right? This looks like a very linear type of graph. So if I want to do a linear regression, y1 squiggle, you could do m or a x1 plus b. And there's going to be your linear equation. Gives you your correlation coefficient r, and then there's your slope and y-intercept down there, so you can estimate that. Now if I change, you can take these off if you want to by clicking on the colored buttons, right? You can take the dot, okay. If I change some of these, so let's get out of here, let's make this more of a quadratic, so let's change 310 into 37, and let's add 4, 5 on there. So now you have like this like U-shaped look. Now we can do a quadratic regression, y1 squiggle. Now we're doing ax1 squared. So let me get the squared back up there. Squared plus bx1 plus c. That is your standard quadratic equation. Notice here, right, it gives you this r squared value, which also says how well the fit is. It's got to be close to 1. And then it gives you your a, b, and c values for your quadratic equation if you had to do a regression. Notice it does plot the curve. You can take the curve away. And then it does do residuals. So just by the slim chance that the state test asks for residuals question, you can plot your residuals. So remember, residuals are the distance between these dots in the black curve. Again, they're plotted down here on either side of 0. You can take all these away. You can take the curve away. You can take the residuals away. You can take the data away. You can put the residuals back. You could zoom in on the residuals, you know, all that fun stuff. Okay. All right, so there is the OST graphing calculator. Again, very much just like Desmos, and my advice to you is if you have no idea what to do on a problem and you have anything you can plug into Desmos, plug it in, get a picture, see if you can see if it can help you figure out the problem. All right, very good. So now you're going to head off to whatever practice test you're working on and practice some practice problems. All right, good luck.